Welcome to Weather Classroom, everyone. I'm Thomas Patrick, meteorologist with Creme 2 News in Spokane, Washington. Happy Friday. Happy final day of April. Here in the Northwest, the weather's been great. Actually, had our warmest day of the year just yesterday. Not quite 80 degrees yet. We'll be seeing that next month. Plenty, I'm sure. And there has been nothing really to show on the radar. It's been very dry the last couple of months, but that actually brings me to my topic for today. We're talking about the Doppler radar. It's one of the most commonly used tools by meteorologists and honestly most people with an interest in weather in general. It would not be a stretch to say that most people have probably looked at a radar online or on their phone before. And as a meteorologist, I can tell you that there are so many more layers to what radar has to offer, and we've developed techniques to analyze that raw data to be able to interpret what we are seeing. So let's cover that topic for today. So first of all, let's just show you something that you've probably seen on any news broadcast or any weather broadcast across the nation. Just a classic Doppler radar map. Actually, a good example here that shows both rain and snow in New England. This is actually the current Doppler radar map as I'm recording this on Friday evening. So this is probably something that you've seen us use maybe every single day, multiple times a day, I'm sure. It is such a common tool to be able to locate where it's raining or where it's snowing on any given day, almost anywhere in the world, but especially here in the US where we have such a robust network of Doppler radars, which is known as a NEXRAD. But it's actually more, there's so much more information than what we're just seeing on the common map here. This is probably something you've looked up online or on your phone as well. You see the red, the yellow, the green shades for rain, and then the white and the blue shades for snow. But it actually doesn't come as rain or snow. That's actually some interpretation of the data or a derived product. There's so much raw data that goes in behind that. So let me actually show you what some raw data looks like. And we will begin with an image of a hurricane. And there are essentially 4 different layers of raw data that what Doppler radar will detect for us. We have the reflectivity in the top left. That's pretty much the standard image of what you would normally see on TV. The velocity, which is the speed inbound or outbound of any kind of object. Differential reflectivity, which actually determines the shape, kind of a shape of an object. We use what's called a dual pole radar, so the signals and the waves that get transmitted from the radar actually come both vertically and horizontally. And raindrops, by the way, aren't the traditional like teardrop shape. Raindrops actually are kind of more pancake shaped because there's the air pressure as they fall. So since they're pancake shaped, the blue that you're seeing in this particular image would indicate, oh, there's a lot of very flat horizontal shapes. In this case, it's going to be rain. And then correlation coefficient, which is how much of the flat versus round, the distribution of these objects. When we talk about Doppler radar, the radar stands for stuff and the Doppler stands for speed. And in fact, the Doppler part of Doppler radar measures how fast something is moving towards or away from where you are standing. So like a race car going by you, it sounds like, and that's the Doppler effect because that sound, that pitch in that case, actually changes as it moves past you. Well, the radar can just sense that, be it rain or hail or anything else that we can see. And there's a lot that we can see, a lot more than just rain or snow. So let's go over some of these examples. Here's a case where we have a tornado. This is actually the Joplin tornado from 2011. On the left side here is the reflectivity or the base map here, and there's that little purple splotch kind of in the middle. Well, okay, there's a lot of stuff there, but it's the velocity that determines, okay, the winds are very fast towards the radar, but very fast away from the radar in a very close proximity. We call that a couplet, which is a good tornado vortex signature. So in this case, we would say, yeah, there's a tornado right here. And of course, that was a very large tornado back in 2011. Let's look at another tornado, this one in Michigan. And this is the 4 plot that I showed you earlier. Not only do we have the reflectivity on the left and the velocity on the right, now we can use the differential reflectivity as well as the correlation coefficient. In fact, it's the CC, as you might see, especially in some Southeastern U.S. TV stations will use this to detect debris within the tornado. It can detect that there's not just rain or hail or debris or anything. It's just a mix mash of everything. Whereas the red around that is very homogeneous. That's the rain and the hail and pretty much just that. But the debris signature, or what we call a TDS, really pops out on this particular instance of the radar. And again, this is all raw data that we can use and say, okay, there's very, very likely a tornado in that case. Here's an example from last year from my own TV station, and this is actually a graphic where I had to point out that this wasn't rain in this case. You can actually see the legend in the top part of the screen here, where usually the radar can determine rain and ice and snow, but in this case, this isn't rain. This is wildfire smoke and the plumes of smoke coming from the wildfires that were getting detected directly by our own Doppler radar. So that was another way to utilize this radar, and we're actually going to hear more about this exact case from my interview from our own National Weather Service here in Spokane in just a moment. But that was very, very useful for us to show on TV. Even though it wasn't rain, it was definitely very important for that day last year. We go back to the hurricane example, and obviously the left is the reflectivity, the traditional image that you would see. A lot of blue on the right side, and the blue is indicating the rainfall, again, those hamburger pancake-shaped rain droplets. But I want to point out in the eye of the storm, see there's a little bit of red right in the middle here. The red is actually birds. That's right. The radar can detect animals in this case. There's not a lot of them because there's not much on the reflectivity side of things, but the red is indicating that these birds are kind of stuck in the eye of the storm. They're taking shelter from the hurricane where the winds are not as intense in the middle here. So we can detect that through the uses of Doppler radar. While we're on the case of animals here, here's another example of thunderstorms on the left, quite clearly. Something going on just below that, or just to the south of that, that's just lit up on the differential reflectivity in the red and the white here. These are bugs, insects that are getting lofted into the atmosphere by the thunderstorm outflows themselves. So they light up in radar in that particular layer of the Doppler radar. And there's one more example, and this one might make a few people queasy, especially if the bugs didn't make you queasy. This is out of Texas. See these almost like little explosions on the radar? These are bats that are awakening at night and going out from their nests to feed for the evening. And the radar was picking up on that biological data. There's so much that we can see and utilize the radar for in a lot of different instances, and this information is available through the U.S.'s National Weather Service. So I went to our own NWS office here in Spokane and talked with our warning coordination meteorologist to see what all the National Weather Service uses it for and all the different applications and what we can see and all the good stuff, because it is such a common tool that might as well talk straight to the source. Take a listen. Joining me now is Andy Brown, the warning coordination meteorologist at the National Weather Service right here in Spokane, Washington. And Andy, it's so great to see you virtually. It has been quite a long time. Hopefully you're having a great Friday up to this point.
Absolutely. Loving the weather outside. I love the cool, cloudy weather. So absolutely enjoying this time of year.
Yeah, I'm sure a lot of the runners who are going to do Bloomsday this weekend are going to be loving this weather as well.
Right.
But
Exactly.
we're jumping into our topic today, talking about radar, because it's something that's we use every single day, and not just as meteorologists, but most people have a weather app on their phone that can show them the live radar at any given moment. And I don't want to take that information for granted. And there's so much the radar can do, more than just that reflectivity that we see on our phone. So from your perspective at the National Weather Service that provides a lot of this data, how much data is in the Doppler radar, and what do you use that data for?
Boy, that's a loaded question. There's so much. The radar is one of our most useful tools that we have available to us. We have all these tools in our toolbox. Meteorologists do. We have the satellite. We have the observations. We have spotters that relay information to us. All of these different tools, but the radar is It's right here in Spokane. It's out on the West Plains, west of Spokane, and it sits at our office, and we use it daily. We truly do use it daily, even when there's uh, no moisture coming out of the sky. We're looking at it. We're looking to see what's happening. Um, so the types of things that we can see, it's not just the rain, the droplets coming out of the sky or the snowflakes. It's how big are the raindrops? How big are those snowflakes? Is there moisture on those snowflakes, or are they melting? Are they almost melted? Um, if there's enough reflectivity or energy coming back to the radar, that means it's a very large, wet raindrop, and there's a lot of them, or it could be hail. If it's big enough, it could be hail. And that introduces a whole other new impact that we have to consider. Um, we can see dust on the radar. During the wildfire season, the large smoke plumes, we can see those. So there's so many different things. And another aspect that we look at during convection, during thunderstorms, is because it's a Doppler radar, we can see which direction the rain and snow is going. So we can actually see rotation, um, or if a thunderstorm is rotating, then it has certain elements that we need to look for to produce severe weather, tornadoes, or very strong outbursts. So there is a lot of information that radar that you might see on your app, like you said, or on the internet. But we're dissecting that and looking a lot into that. And
Yeah.
I'm very sorry for the dogs in the
Oh
background.
no, no, not at all. I can say, as a meteorologist that has worked in different markets in South Dakota and Illinois and now Washington, I mean, just it was actually quite a leap because as a severe weather meteorologist in the Midwest, we're obviously looking and dissecting not just the reflectivity but the velocity to be like, oh, here's the
Right,
rotation, here are these other things.
right,
And then I come here to Washington, and it's like, okay, we don't get as much severe weather. Hopefully, we don't ever see tornadoes, and they're very few and
right.
far between here. But then we started using the radar for so many other things, and I think one of the most telling things that I remember from last year was our wildfire ignition day. It was on the
Yeah,
Labor Day of last year,
Labor Day.
and
Right.
the smoke plumes were on
Yep.
radar, and I remember having to
Yes.
explain that to be like, okay, we're getting the green, which is usually rain, and 99% of the time, but it's not rain, it's actually just smoke plumes. And there's
Yes.
just so much that we can see beyond precipitation, especially when it comes to western meteorology, right?
Absolutely. And that it becomes very useful because those, especially on September 7th, there was also blowing dust. There was smoke from other fires that was limiting visibility. So when a new fire would pop up, folks that were on the ground might not be able to see that. So they were relying on the resources that the Weather Service had to look at the radar and find that point of where is that new smoke plume coming from, and also using our satellite imagery to actually find where that smoke plume was originating. And we called a different agency, a land management agency, and say, we're seeing a new wildfire in this location. And they say, okay, we have somebody going out to look at that. So we're actually using that to detect new wildfires and help relay that information. On a day where there was no rain in the atmosphere, there was no rain coming out of the sky, we were still using our radar to help notify other agencies of how to respond to those fires.
Yeah, it's such a great tool, and because especially with such the rural areas that we have, all the mountains, it's just like no one's gonna be standing next to that tree and be like, "Oh, that's burning. I should call somebody." It is
Right.
incredible that you could be the you could almost be the first responder to be like, "Hey, it looks like
Exactly.
there's a wildfire right here."
That's exactly what we do. And I was working in operations on that day, and that's what we were doing. We have a new wildfire here, a new wildfire here, and we were keeping track, making phone calls, and relaying that information to the people that needed to respond, and made sure that they are aware of those.
Yeah, that's incredible. I do want to ask you about some other unique things that you've
Okay.
seen on radar because we've covered rain and snow and even
Oh
grapple.
yeah.
When the
Yep.
water droplets are collecting on those snowflakes, wildfires, and even some dust. Are there any other weird things that you've noticed on the
Oh yeah.
radar over the years?
So it's hard to see sometimes with the Spokane radar, but I've seen this example in other large cities. You can actually see traffic movement. The radar, once, if there's no rain or particles in the atmosphere, we put it into a different volume scan. So the radar beam or the radar dish is actually moving slower, and it can receive more data.
And that's
And so
clear
the
air mode,
slower it
right?
moves, yeah, and so the slower it moves, you can see more and more of those things in the clear air mode. So I've seen that if there's enough traffic, you can actually see the traffic going different directions. I spent quite a bit of time in my career up in Alaska, and I've seen volcanoes erupt. You can see the ash coming up from the volcano, and then the movement as the ash, the wind pushes the ash, and the ash starts to fall out. So we've seen that. Likewise with the traffic, um, up in Alaska, there's Cook Inlet, which is off of the Kenai Peninsula, is covered in ice for most of the winter, and so you could see the tides actually bringing in the ice and then removing it. So you could actually see the tidal movements
Wow.
in Cook Inlet on the radar. So that's not very useful. It's just very cool to see sometimes. Obviously, the ash from the erupting volcano was very helpful. We really utilized that tool, but um, we've seen some pretty cool things that every now and then you take a step back and like, wow, I'm seeing a lahar off a volcano on a radar. That's something that just doesn't happen very often.
Yeah, I can't say that I've ever seen that, but I have seen the cars on the interstate back when I worked
Yeah, yeah,
in Illinois. It was basically there was this perfect
yep,
cross section of I think it was I-55, and the radar was straight down the
just
interstate. I
perfect.
mean, it's just straight as a nail too, and especially on those clear air days, it's just like, oh,
Yep.
I've got this bright red pixel. It says 70 miles per hour, and this bright blue pixel, and it says 70 miles per hour. I wonder if that's traffic
Yep.
going both ways.
Yep. Certainly isn't a tornado.
Yeah, no, I don't think we'd consider that a couplet.
No.
Okay, there's one more question I wanted to ask you, and it's for
Sure.
Spokane and for most Western U.S. areas. Are there any challenges when it comes to radar coverage, especially if we have to
Right.
play around the mountains and not necessarily the
Yeah.
coverage gaps? Because obviously, with the cities farther and farther between, sometimes the zones that they can see are maybe not quite intersecting. But with the mountains
Right.
overall and the terrain, how do you manage trying to collect as much information as possible? And are there any challenges or things that might just be out of reach for the radar,
Right.
especially in these regions?
Yeah. Terrain definitely comes into play, and how much we can see. And as you mentioned, in the West, our radars are farther spread apart. In parts of the Midwest or Southeast, the radars are actually pretty close to each other, but that's because they have more population and they have the severe weather where they need to get that really high resolution information. And so they have these radars that are pretty close to each other. In the West, you just don't have as much population. It's spread out more, so the radars are also spread out more. One thing that we haven't talked about yet is radar is not just one slice. The lowest slice that we have is 0.5 degrees off of the horizon. But the radar gives us several slices as it goes and points almost directly up above us. So it's not just one layer that we're seeing an entire volume, which helps us get a better picture of what's happening in the atmosphere, not just at one layer.
In 3D
So
space.
there are some uses in that close by we can see a lot more things, but Mount Spokane blocks our radar to the northeast, but we still have radar scans above the Mount Spokane that we can still see a lot of information past beyond that. Um, the other thing I wanted to say about that was, as the radar beam goes farther and farther away, it's actually going away from the curvature of the Earth. So as it goes away, the radar beam is doing this, while the Earth is
Curving
doing
away.
this. So 90 miles away from the radar, that beam, it's sampling at about 10,000 feet above the ground. So that's 10,000 feet of data that we're missing. And the farther you go out, the higher that beam gets. So that's a lot of information that we're missing and that we can't see with the radar. And that's where those other tools that we have come into play. The satellite is very useful in seeing what's happening, but then we also rely on the observations and our weather spotters to relay that information. It could be snowing in Leavenworth, and we would have no idea, or Bonner's Ferry, because the cloud and everything that's happening to produce that precipitation is in the lowest 10,000 feet of the atmosphere. And we can't see that on the radar. So that's when we start to call our weather spotters, or we use the webcams that are available, and use other types of observation techniques to see what's happening in that. So it's not perfect, but we supplement where we can, to help us see what's going on where the radar can't show us that.
Yeah, and I've even seen that, especially when you mentioned like Leavenworth or even OMAG, Northern Washington. I mean, your two radar beams are Spokane and Seattle, and they've got a
Right.
big mountain range in between them. It's
Right.
just like, well, who's covering the kind of in the middle part there? And anybody that's even seen a weather image or like a radar image on their phone, it'll be
Yeah.
like nothing, 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 and it just like all pops up green because like the data is just barely coming in. And yeah, it's great to
That's
have
right.
all those resources that kind of fill in the picture. It's like a puzzle piece, and you can't. It's not just one piece. Here's the radar. It's just we got to have all these other things if
Exactly.
we're missing to help to interpolate that data.
That's right. We call when we have weather going on, and we need to dedicate one forecaster to the radar watch. They are interrogating the radar. They are like an investigator that is seeping through all of this information and trying to find out exactly what's happening. So radar is a very important tool, but it's just one. And so we have to supplement where we can and figure out exactly what's happening, how much rain is coming down. Is that going to cause a flash flood, or is it hail? All those questions that we have to figure out. That's what the forecaster is doing when they're interrogating the radar information.
I love that terminology. I'm going to use that on air. I'm going to be like, I'm
Good.
not analyzing the radar. I'm
I'm
interrogating it.
interrogating.
I love that. Well, Andy, I got to thank you so much for your insight at NWS to interrogate the radar and being our experts there. It's just wonderful to get your perspective on all these things.
Awesome. I appreciate it. It is a lot of fun. We are blessed to have a radar here co-located at the office, so we get to see it and check it out. And it is a very useful tool. I wish we had more across the country, but the ones we have, we certainly appreciate and we use every day.
Yeah, and next time we meet, hopefully it's in person, so that way we can
That's right.
see the dome itself, and maybe if we
Absolutely.
stop the dish from spinning, we can go take a peek inside, right?
That's right. Absolutely.
All
We'll do
right.
our best.
Well, Andy, thank you again so much for joining me today. I
Yep.
really appreciate that.
Absolutely. Thanks, man.
Now, check this out. This is actually from the National Weather Service in Spokane. The last time they had to do maintenance on the radar dish, they actually had to take the dome part off in order to do some maintenance on the pedestal on the inside. And actually, did you know that that dome part, that's not the radar itself? It actually just protects the Doppler radar underneath it all. And so it actually just has to protect it from the weather, the thing that it's trying to see. Usually, hail and wind would be the most threatening to the radar dish or satellite itself. So it's actually the dome part that protects it. Now, in this particular instance from the National Weather Service, there's actually no satellite dish. They disassembled the Doppler radar itself while it was still inside the dome and took out the pieces that way. But then they had to take the dome off in order to do some maintenance on the pedestal. So that was the last time that the National Weather Service had to service. So the next time that you see that and you see that dome, that white ball on the outside, that's not the radar itself. It's actually a satellite on the inside. Now, Andy did promise me that he was going to send some video my way of the inside of the dome with the radar still attached. He's gonna get that to me this weekend, so look for that video on my Facebook and my Twitter pages. By the way, you can follow me on social media anywhere as long as you search at Thomas Patrick WX. You can find me Facebook, Twitter, Instagram, Snapchat. Don't worry, you'll find me online if you search that for yourself. So yeah, that is awesome to see a little bit of what is inside, but look for more over on social media. I'll leave you with this, a bit of just our forecast for this weekend across the U.S. The big story really was the winds on the East Coast, mostly from today. One of my best friends, a meteorologist in Washington, D.C., had some quite fierce winds that they've been tracking. So D.C., Dover, Delaware, Philadelphia, Pennsylvania, getting the strongest of the winds, actually under a high wind warning for today with those strong winds all along the East Coast. This is actually a day after the cold front moved through that region. So it's just the pushing winds, those driving winds that were behind that system. Still pretty feisty for tonight and through tomorrow morning, but hoping for a calmer weekend overall. Hopefully it is warm for your weekend, the first weekend in May. Actually, almost exactly the opposite of what I had the last time I did this weather classroom. I like to show the national temperature map for Saturday. Last time it was like cold in the heartland. This time it's going to be warm, almost 90 degrees in Omaha, Nebraska. So hopefully you're going to have a great weekend. It's going to be really nice here in the inland Northwest in Spokane, Washington as well. But that will do it for me today. And the next time that you see a radar image, perhaps you'll have a bit more insight to analyze or interrogate it, as Andy mentioned. If you'd like to see any previous episodes of Weather Classroom, be sure to find those both on my YouTube page as well as the Creme 2 News YouTube page. So make sure to subscribe, like, comment, all the good stuff. And if you subscribe, you will not miss a future episode, and we will, of course, be back next week. Thanks again for watching. I'm Thomas Patrick. Have a great weekend, and we'll see you next time.